So for years now, I've been saying that robotics is another exponential technology that's exponential due to AI. Is that really true? We're going to find out right now with a great article straight from the researchers doing this research, and it's a major breakthrough in robotics. Researchers at ETH Zurich and Max Planck Institute for Intelligent Systems have developed a robotic leg with artificial muscles. So what does that mean for robotics? Inventors and researchers have been developing robots for almost 70 years now. Isn't that a trip? And as my viewers know, the first industrial robot was invented in the 60s for GM. To date, all the machines they have built, whether for factories or elsewhere, have had one thing in common. They are all powered by motors, a technology that is already 200 years old. Even walking robots feature arms and legs that are powered by motors, not by muscles as in humans and animals. This in part suggests why they lack the mobility and adaptability still of living creatures, although, as my viewers also know, their mobility and adaptability is getting better and better all the time, but this is a whole new level. A new muscle-powered robotic leg is not only more energy efficient than a conventional one, it can also perform high jumps and fast movements as well as detect and react to obstacles, all without the need for complex sensors. The new leg has been developed by researchers at ETH Zurich and the Max Planck Institute for Intelligent Systems, as I said a minute ago. By the way, if you like this video so far, please like, subscribe, and share. Also, please support us on Patreon. We really need your financial support to keep bringing you breakthroughs from the cutting edge of AI, robotics, sensors, and all the other exponential technologies being driven by AI. We really need your support. So thanks so much, and let's find out more about this robotic breakthrough. As in humans and animals, an extensor and a flexor muscle ensure that the robotic leg can move in both directions. These electrohydraulic actuators, which the researchers called hazels, are attached to the skeleton by tendons. Note the replication of the way living creatures' mobility works. Conventional robotic legs are driven by electromagnetic rotary motors. For the musculoskeletal system of the new robotic leg, researchers use electrohydraulic that are essentially artificial muscles. The actuators are oil-filled plastic bags similar to those used to make ice cubes. As soon as we apply a voltage to the electrodes, they are attracted to each other due to static electricity, and they say this is similar to rubbing a brush on your hair and it stands up. As one increases the voltage, the electrodes become closer and push the oil in the bag to one side, making the bag overall shorter. Pairs of these actuators attached to a skeleton result in the same paired muscle movements as in living creatures. The researchers use a computer code that communicates with high voltage amplifiers to control which actuators contract and which extend. The article mentioned these are more efficient than electric motors. The researchers compared the energy efficiency of their robotic leg with that of a conventional robotic leg powered by an electric motor. Among other things, they analyzed how much energy is unnecessarily converted into heat. This is a byproduct of all motors. They generate heat. On their infrared image, it's easy to see that the motorized leg consumes much more energy if, say, it has to hold a bent position. The temperature in the electrohydraulic leg, in contrast, remains the same. Typically, electric motor-driven robots need heat management systems. So all these things add up extra cost, right? The heat management, the sensors, the additional algorithm elements, all this stuff adds cost. So in the end, when this new technology is fully developed, it'll be much cheaper, and robots will therefore get much cheaper. Final mind-blowing comment in a minute. In contrast, the artificial muscles, which work on the principle of electrostatics and are efficient, remain cold because no current flows through them under a a constant load. So in other words, these artificial muscles react and then they don't need any more energy, where the conventional motors have to have higher energy to make them hold still. Agile movement over uneven terrain. The robotic leg's ability to jump is based on its ability to lift its own weight explosively. The researchers also showed that the robotic leg has a high degree of adaptability, which is particularly important for soft robotics. Only if the musculoskeletal system has sufficient elasticity can it adapt flexibly to the terrain in question. It's no different with living creatures. In contrast to electric motors requiring sensors to constantly tell what angle the robotic leg is at, the artificial muscle adapts to suitable position through the interaction with the environment. This is driven by just two input signals, one to bend the joint and one to extend it. Upon landing, the leg joint adaptively moves into a suitable angle depending on whether the surface is hard or soft. So this is a major breakthrough, as I said. Emerging technology opens up new possibilities. The research field of electro-hydraulic actuators is still young, having emerged only around 6 years ago versus 200 years ago for motors. The field of robotics is making rapid progress with advanced controls and machine learning, the software side. In contrast, there has been much less progress with robotic hardware, which is equally important. This publication is a powerful reminder of how much potential for disruptive innovation comes from introducing new hardware concepts, like the use of artificial muscles. Compared to walking robots with electric motors, our system is still limited. The leg is currently attached to a rod, jumps in circles, and can't yet move freely. Future work should overcome these limitations, opening the door to developing real walking robots with artificial muscles. If we combine the robotic leg and a quadruped robot or a humanoid robot with two legs, maybe one day when it is battery powered, we can deploy it on a rescue robot. So here's where I blow your mind. A month ago, I talked about how real skin had been invented that can be attached to robots. Now you add a real muscular structure and the skin, and you've really got stuff walking around eventually in public that will be very human in appearance. How does that blow your mind? And it is coming. Because eventually all these separate research breakthroughs come together in something real in the physical world. That's how it works. So thanks so much for tuning in. Please like, subscribe, and share this video. That really helps with the algorithm. Also, please support us on Patreon. We really need your financial support, especially prior to us getting monetized. But we are getting closer to that. So thanks so much for tuning in. We'll see you next time. Take care. Bye.